All right, so we're going to do 4.1b. And 4.1b has two parts. We're going to learn two things, and they don't really go together. It's kind of funny. We're going to do navigation and speed. I guess those kind of go together, but they're not really put together. Navigation and speed. Doesn't that sound exciting? No? Okay. All right, letter A. Here we go. Let's start with, anyone know how to use a compass? Is that how you spell compass? Like a compass, you know, like a north, and it has a little needle, and it tells you which direction to go. Yeah, circle. A compass. Oh, I see what you mean. No, like a Boy Scout, and you're out in the wilderness, and you need to find your way back home, and they give you a compass. Would you know how to use that? I don't. No. My son does. He's pretty good. Because he's in cadets, so he has to know how to use a compass. It was part of the field day thing. Anybody go to field day when they were a kid? No? Okay. All right. Anyways, now, when we talk about the direction of like a boat or an airplane, we talk about its course that it's on, or its bearing, what bearing it takes. Okay? The course or bearing that a boat or a jet takes is given as the angle of the line of travel. The angle of the line of travel. Now, how do we decide what angle this is? Well, the angles are always going to be measured clockwise, okay, which is different than what we're going to do in a lot of trig stuff, but it's measured clockwise from due north. From due north. Okay, I'll show you an example of this. So the course or bearing that you take, and this is today is just showing you what it is. When we get to lesson 4.8, which is the last lesson of the chapter, we actually do application problems involving this. So like if I said that a boat was traveling, so for example, 155 degrees. Okay. Well, if I wanted to look at that from up above or from a map, what you do is, here's north. Okay, that's due north. And from due north, in a clockwise direction, we're going to take an angle of 155 degrees. So in other words, I would go start here, and I would go, that's to 90. It's exactly 90 degrees. And then 155 is about there. And we don't have to be exact, okay? But that would be the direction that the boat would be traveling. That's 155 degrees from the north. Okay? So you could go all the way to like 355 degrees would be over here, which is kind of funny because you're like, just go 5 degrees that way, you know, but no, you have to go all the way around to there. All right, so what we're going to do is we're going to have a compass, and the compass is on page 325. I'm going to draw some of it for you, but the entire thing is on page 325 if you need it. So here we go. Let's say we have a compass. It's a pretty good circle there. Whew. And I don't know about you, but how do you remember what order things are in on a compass, like directions? What do you say? Never eat sour watermelon. Soggy waffles, yes? Soggy waffles? Never eat soggy waffles. Soggy waffles are good, though. They have so much syrup on them. Do you say syrup or syrup? I say syrup to bother people. Uh-huh, it does, huh? Or caramels. Do you like caramels?
No.
I know, but I say caramel. Like, I want a caramel macchiato. And then it makes people really mad. Or you say cabinets. The cabinets in the kitchen need some cleaning. Or, yeah, cabinets.
Have you heard Let's Go on Holiday?
Holiday, yes. It's vacation. You're right. Okay. Anyways, what they do is they will break this down into even smaller increments. So north, east, southwest. But what if I want to go halfway between here? I would call that northeast. Yes. Northeast. And then over here, be careful, halfway between, Southeast. Yes, you got it. It's not east-south. It's southeast. Okay? It's always north or south first in all of these halfway in-betweeners here. So this would be southwest. I hate flying southwest. And this would be northwest. And then guess what they do? They break it up again. What? Yes, crazies. All right, what they do is they take halfway between north and northeast, and they call that north, northeast. See how we're north of northeast? Yeah? Okay. And then this one here is going to be east of northeast. Do you get the idea? Okay. Do we need to fill in any more? They're all on page 325 if you need them. Let's fill in like one more. I feel like I need one more. So let's go over here. I'll go green now. This one right here, that way would be called what? Anybody know?
Southeast.
It would be east, southeast. Yes. So it's east of southeast. Okay. That's good. That's good enough, right? Or you want one more? You want one more. And this one would be what? South of southeast. Good. Okay. So we get the idea. And now what are we going to do with these? Well, we're going to have fun. Here we go. Example number 1. Example number 1. All right, it says, what is the bearing of, we'll do 2 of them. What is the bearing of east, northeast? What is the bearing of east, northeast? Okay, don't forget, bearing is from the north and it's in a clockwise direction. So what we need to do is we need to find out where east, northeast is. Here it is. And I need to take from the north and go that far. Do you see that? The red degree? Do some of you know it already? Yes. Okay. So let's find out how Ricky got that. All right. So what we're doing is we are going to break this up into degrees, right? So right here, this would be a 90-degree angle. And then if I split it in half, I'm at what? 45. And then I split that one in half, I'm at 22.5. 22.5 is kind of the magical number here, isn't it? All of these little ones from the black to the blue, from the blue to black, all of those are 22.5. So you can look at it a couple of ways. You can add up all the little 22.5s all the way around until you get there. Or you could go, okay, to northeast is 45, and then just east of that is another 22.5, and so my angle would then be 67.5 degrees. Okay? So that 22.5, that's the key on all of these. So let's do another one. Let's do, what's the bearing for west of northwest? West of northwest. Well, let's find out where west of northwest is. West of northwest is going to be, so here's northwest right here, and west of that would be towards the west. That makes sense. West, north, west. Okay, so what you can do is we're looking for, what color should I use? I'll just use yellow. We're looking for the angle from the north all the way around to north or west, northwest. Do you know what that angle is? 292. Good job. That was fast. Okay, I'm assuming that you went 270 all the way to west. To west is 270, 90, 90, 90. And then you added that special angle, that 22.5 degree angle, 292.5. Perfect. Any questions on that? Is that confusing? It's pretty good. See, this is real life applications. You go out, you get lost? No, not quite. Okay. All right, here we go. Now, here's the other type of question you're going to get with these problems. Number 2. Which compass direction is the closest to 219 degrees? So this is going the opposite direction, right? Not the opposite direction, but the opposite problem. Which, what did I say? Which compass direction, is closest to 219 degrees? Okay, well, 219 is definitely over 180, so we're definitely going to be over here in quadrant 3. So let's find out where we're at. So 180, and then 270 is to there. What would half of that be? That would be 225? Is that right? Yeah. So that's 225 to there. And if I went a distance of 22 back that way or 22 and a half back that way, it's not going to be any closer to 219. So it's going to be that one. So that one right in the middle there. Which one is that? Southwest. Perfect. Southwest would be the answer at 225. Okay. I'm feeling pretty good about your compass skills. Let's move on to part B now. Last part. Part B. We're going to talk about speed. And when we do these problems, there's going to be two types of speed. We're going to talk about the speed of how fast the angle is going inside the circle and how fast we're going on the outside of the circle. So we're going to have something called angular speed. You're ruining my video. You know that, right? I'll sit you in the back. Never mind. I'm sorry to interrupt you. I'm sorry. Angular speed and linear speed. Okay, angular speed is measured in revolutions per minute, usually, per time. Let's just write per time, because it could be per second. It could be something like that, okay? Now, how many radians is an entire revolution? Do you know? 2 pi. Okay. 2 pi radians is 1 revolution. That is going to be very key with angular speed. Okay? 2 pi radians is 1 revolution. You guys all believe that, right? 1 pi is to 180. All the way around is 2 pi. So 2 pi radians. All right, the other speed that we're going to do is linear speed. And this is going to be the speed on the surface of our circle. Okay? Linear speed is always going to be measured in distance per time. Like, for example, when you're driving down your street, you measure your speed in what? Miles per hour, distance per time. Okay? And the thing about linear speed is 1 revolution is to go all the way around the circle. On the outside of the circle, what is that? It's the circumference. Yes, 2 pi r is 1 revolution. Now, these look very much alike, right? The only thing is, this is missing r for angular speed, and it's there. So angular speed doesn't have to do with the radius of the circle, but linear speed does. Okay? And we're going to do 2 examples. Here we go. Number 3. All right, we're going to find the speed of the second hand of a clock. Okay? So it says here that the second hand of a certain clock is 10.2 centimeters long. We are going to find the linear speed of the tip of the second hand, okay, the linear speed, in centimeters per second. Now, I will always tell you what units I want. The book doesn't sometimes. It's really annoying. Like, what do you want this in? You know, you want this in feet per second or whatever. But I will tell you what your units are. And that helps you because, I don't know, I like to set these up like this. my end is going to be, the end of this problem is going to be something centimeters per second. That's my goal. I want to get there. And so I'm going to set up stuff that I'm going to go ahead and reduce units and stuff so that I get centimeters per second. All right, so let's go ahead and start. Here we go. I need seconds on the bottom, and I know that one revolution around this circle, around this clock, takes how long? How many seconds does it take to go one revolution? 60 seconds. Perfect. One revolution is 60 seconds. Now, they didn't give me that. That's just common knowledge, right? One revolution around that clock is 60 seconds. So guess what I have? I have revolutions per second. I'm halfway there. Now I need centimeters. So I got to get rid of revolutions. So I'm going to use that one revolution of this clock is 2 pi r. 2 pi times 10.2 centimeters. Make sure you include units in your problem when you're working it out, okay? Does this remind you of that stoichiometry stuff in chemistry? Yes. That was the only part I liked in chemistry. Actually, I mean, I liked, yeah, that's probably about it. Yeah. Okay, so revolutions are going to reduce, and you end up with what you need, centimeters per second. By the way, the book teaches this a totally different way. So if you like that way, that's great. I like to set it up like this because I like to reduce my units out. All right, and then you just go ahead and you multiply and divide. So 2 pi times 10.2 divided by 60. So it's about 1.07 centimeters per second. That's how fast it's going around the clock. All right, number 4. Okay, it says that a certain truck has wheels that are 36-inch diameter. That's not a very big wheel, is it? The diameter? Like, what do they measure, like, cars at? Is it the radius? Like 20-inch wheels? What does that mean? I think my car's 22. I don't know. I don't even care. Okay, all I know is I need new tires, and they're very expensive. I've been shopping around. Truck wheels are 36-inch diameter. And it says here that this guy's driving along, and his wheels are rotating at 630 RPMs. Do you know what RPMs mean? Revolutions per minute. Okay? Now, what we're going to do, we want to see how fast he's going. We're going to find out his speed in miles per hour. Find the speed in miles per hour. This is tough. Okay. Once again, super nice. They told me what I need at the end. I need miles per hour. Okay? All right, I'm going to start with the rate that they gave me. They gave me a rate of 630 revolutions per minute. So I'm going to start with that. 630 revolutions per 1 minute. Okay. Am I halfway there? No, not even close. I have minutes, I need hours. Let's go ahead and change that right away, okay? So I know that 60 minutes is equal to 1 hour. All right, so my minutes reduced. I have hours, yay, halfway there. Now I need miles, and I have revolutions. So I got to get rid of revolutions. So I know that one revolution around this tire is how long? What's the distance? This is linear speed. What's the distance? Yes, 2 pi, well, it's 2 pi r. Okay, so it's the circumference of a circle. So this would be 2 pi times 18 inches. Or you could have just gone 36 pi if you wanted to. Right? Diameter is 36, which means its radius is 18. Be careful with that. 2 pi r, radius. Okay, so now my revolutions are gone, and I have inches per hour. Uh-oh, I need miles per hour. Did you have a question? Yeah.
Why is it 18?
Oh, 36 is the diameter, so that's all the way across. So I need to take half of that for the radius. Okay, so I have inches per hour. I need miles per hour. So I know that there are 12 inches in 1 foot. I'm running out of room here. And then, do you know how many feet are in a mile? 5,280. 5,280 feet in 1 mile. I ran out of room, didn't I? Is that the eraser? There we go. Now, if you didn't know that, because let's say you're used to kilometers instead in your country, in your land, you could ask me. I would tell you. Okay? So, a lot of people don't remember. How do you remember that? 5 tomatoes?
Yeah.
Yes, I know, right? Isn't that so stupid? But it's good. Okay, so are we there? Let's see. Inches reduced, feet reduced, and guess what? I have miles per hour. So let's go ahead and find out how fast this truck is rolling along. So we're going to go with 630 times 60 times 2 pi times 18. And then we're going to divide that by parentheses 12 times 5,280. I got, what'd you get? 67.5 approximately miles per hour. Hopefully he's driving on the freeway and not in your neighborhood. Okay?